Hello, my grade 10s. The lesson today is on discrete and continuous data. And when we talk about data, it can be taken and then graphed. So often we look at deciding whether data is in fact discrete or continuous as to how we're going to then graph it. So let's start off, first off, with discrete data. Okay, and what the graphs will look like. Now, discrete data is the result of counting. Okay, so you're going to count things, like you might count, that you're going to buy a certain number of apples. So that would be counting. You count as you put them in your bag. You would not be able to put a half an apple in the bag or a quarter of an apple in the bag. And so that's the way we can think of discrete data as well, where if we're counting, we can't be counting parts of something. So it can only take certain values, okay? Most often it's whole number values, but not in all cases, okay? But still only certain values. The data on a graph would look similar to the four examples that I have here. Now, before we get to that, I just want to do a little bit of a review of what we did before the break on graphs. Now, at the bottom, we have the X value on a graph, and this is in fact tickets in this example, but this is the independent variable, okay? And the tickets will determine the cost that is being spent. So if you're going to order tickets, the number of tickets that you order will determine the cost. And this is on the y-axis, and this is the dependent variable, okay? So when we look at this graph, if you buy 0 tickets, it's going to be 0 cost. So in fact, you could see that we could actually probably plot a point there. And then as you buy, say, 1 ticket, it's going to be $20. 2 tickets is going to be $40. 3 tickets is going to be $60. You get these distinct or discrete points on the graph. The points are not joined together because if you join them in a line, any part of the line is part of the graph. Well, you can't have, say, a point in here where you would buy 1.5 tickets or 1.25 tickets. So this is discrete data, okay? The same idea with the next example where we have months. Time is most often the independent variable. It ticks on, right? And the amount of money you might save for a purchase. Like maybe you want to buy a computer and you'll put $10 in an account each month, or maybe $100 in an account each month from your paycheck to purchase that computer. So each month that goes by, you'll see another lump sum that's been added to that account. Okay. Another example would be if, say, you go to Costco and the number of samples that they're going to give away, it's going to depend on the number of customers, right? So if Costco has more samples, it doesn't mean they're going to get more customers that day. So this is definitely the independent variable. So the number of customers is going to determine the number of samples that are going to be tasted. Okay? Now, in the first 3 examples, it looks like all of that data is running, in fact, in a straight line. Now, I just threw in this next example to show you that not all discrete data necessarily has to form a straight line, okay? So let's kind of recap this again. Discrete data are examples of numbers of things, counting. So the number of pizzas ordered. A way to think about it is you can't order a half a pizza. Okay, another example is, say, the number of students in a class. We can't have 12.5 students in a class, right? We're counting whole things. Now, there are a few examples where it's not exactly whole. Like one of the things I can think of is shoe size. So you can purchase shoes in a size 7, a 7.5, an 8, an 8.5, a 9, a 9.5. So you can have half sizes, But you can't have a 9 3/4 and or a 9.2 size. So there are discrete sizes that you can have, only certain sizes, right? And that's what gives you a discrete value. So if we have discrete data and we want to graph it, the points are not connected. And that's because we can't count parts of students example 2.5. We can't order parts of a pizza example 3.5. So this is how we determine whether something is a discrete set of data or a continuous. Let's move on to the second example, okay, or the second type, which is continuous data, or the graphs that come from continuous data. These ones usually result from measuring something, not from counting. And that means that the values have range. And often it's the infinite set of range. So the data on a graph will look more like the examples here. Again, we're still going to have the independent on the bottom, that's our X, and the dependent, which is our Y. So the number of pounds, say, that you buy in bananas will determine the cost that you're going to pay for those bananas. Now, you can put in any size of banana or any number of bananas, and we can get a full range of numbers. So these can be, in fact, joined together because you can get 2.2 pounds of bananas, you could get 2.8 pounds, you could get 2.5 pounds. There's any combination of that, and that will then determine the cost that you pay for the bananas. Okay? Again, time keeps ticking on. Time will be in years and in months. We can be broken down into days, into hours, into minutes, into seconds, fractions of a second. So this will be continuous. So say an example like this. Maybe we have a bucket that has a hole in it. And the more time that goes by, the more the volume in the bucket decreases. So this is a leaking bucket. And as time goes by, the volume is going to be decreasing inside the bucket. Little by little, time by time, small amounts of volume will trickle out. And we can, in fact, join that together to get a continuous line. Another example is temperature. Again, if you think about the temperature over the course of a day or over the course of a year, right? It's cold at night and it starts to warm up over the day. At any point in the day, you can take the temperature and graph it on this line. So it is, again, going to be continuous data. So the points can be joined together and form not necessarily a straight line like we have here, but it can sometimes, again, be a curved line. Okay, and there's just another example. All right, so let's get down to things, thinking about just the data. So like the weight of a baby. Babies can be different weights, and we break those weights down into smaller and smaller parts. I just had a nephew that was born at 8 3/4 pounds, right? He's part of a pound. Or we would say 8 pounds and 12 ounces, something like that, right? Also, the height of students. There's such a range of students. If we had enough students, we in fact could have a line that would join, and there's an infinite set of points that could be joined together. So remember, these are things that we're measuring. Weight and height are things that are measured, okay? And why is it? Because you can have babies that weigh, say, 8.6 pounds or 8.5 pounds or 8.55 pounds, right? We can have students that will measure a certain height, 5 feet, 7.5 inches, 5 feet, 4 3/8 of an inch, right? So you can have parts, and those parts that you're measuring can get smaller and smaller so that it becomes continuous. So now, how do you decide if something is going to be discrete or continuous. So when given the data, you need to be able to decide. So you need to think, does it make sense to connect the points? Remember, it is discrete. That means you do not connect if you can't have part of something, right? You can't count part of a person. You can't buy half a banana, okay? So part of a person and half of a banana, those are things that we would think of as discrete because it's not possible to, in fact, purchase those or count those. It is continuous. That means continuous means you're going to connect if you can have part of something. So somebody could eat part of their meal. Yeah, they can only order. So ordering a meal would be discrete, but eating would be, in fact, continuous. You can buy 2.8 kilograms of bananas or 2.4. You can buy different amounts of bananas in weight this way, but not in whole banana, but only in whole bananas, right? You can't buy a half or a quarter of a banana. So it has to make sense to whether you would connect the points to make it continuous or not connect the points if it's discrete. Okay, the next part we want to look at is actually being able to graph continuous and discrete. So these are some examples. We're going to do the graph. We're going to decide whether it should be continuous or discrete. So let's look at the first example. So the first example, there is the Magic Club. Now the Magic Club has 3 members returning from last year. They set up a booth in the multipurpose room to recruit more members, and an average of 2 new members sign up each day. We want to know what is the total number of members for X days. Okay, so with this, what we want to do is you're going to have an assignment on this. You're going to have to come up with 3 points of data that you're going to put on the graph. You need to label the graph, decide which is the dependent and which is the dependent and the independent on the graph. There's a little bit of a hint here. Okay, so we've got X telling us here X days. Remember that the X is located here and the X is the independent. Okay, so we're going to label this with days. We need to put a scale on this, so we're going to start with day 1, day 2, day 3, 4, 5, 6, 7, etc. Okay? Now the other thing that we are going to put on the graph is the number of members, right? And so that's going to be the dependent variable. Whoops, get rid of that. Sorry. So this is members. Now, I don't want to start with a scale on this until we sort of decide on what the data is going to look like. Now, we know that the dependent one we can give, or sorry, the independent one we can start with right away because that determines the independent, determines the dependent. So the number of days determines the number of variables. So we need to plot 3 pieces of data. So let's start at day 0. Okay, at day 0, remember that there were 3 members that returned from last year. So at day 0, you're going to start with 3 members. And then at day 1, you have day 0 plus, it says 2 new members are going to sign up on that first day. So day 0, which is in fact 3 members, plus 2 new members is going to give us a total of 5. Okay, let's move on to day 2. On day 2, we go from day 1's numbers plus 2 more. And remember, on day 1, we had 5 people, so 5 plus 2 is going to give us 7. Okay, so we have members that go from 3 to 5 to 7. So we need to think, okay, if we start at 3, then we went 4 and 5 and 6 and 7 and 8 and 9. We knew we only had to get up to 5. So we will, in fact, plot our first set of data. So at day 0, we had 3 members. Plot our point. At day 2, we had, day 1, we had 5 members. At day 2, we had 7 members. Now we need to decide, should we join our points or not? Is it possible at day 1/2, right? To, in fact, if we were to join our line here, we'd end up with a point somewhere in here. Is it possible to have, right, part of a day and say part of a member, right? No, does not make sense to have part of a member joining. So in fact, this is going to be discrete data, and we are not going to add a line to join them together. So at the bottom here, we're going to have to decide, should this be discrete or continuous? Well, it's going to be discrete because we can't have part of a member. Okay, so label the axes, give it a scale, plot your 3 points, and decide, should it be discrete or continuous? If it's discrete, we don't join our points. If it's continuous, we will join our points. Let's go to a second example. Okay, so Sarah ate an egg with that should be with 90 calories inside that egg. And she also ate X servings of cereal with 210 calories inside that serving of cereal for breakfast. So what is the total amount of calories she consumed? So the first thing we need to do is to figure out which is the dependent and the independent. So we've given an X here for servings. So the X is the hint. Remember, this is the X and this is the servings. Whoops. Of cereal, okay? And this is in fact going to be the other thing that's being measured here is what is the amount of calories. So again, this is the independent. So this is one where we can just start off at 0, 1, 2, 3, 4, 5, 6, 7, etc. servings. Don't think she's going to eat 7 servings, but if she did, how many calories would that be? Now, before we work out our scale on this side, right, we need to figure out what the values of data we're going to have. So let's look at at serving 0. Okay, at serving 0, it means she has 0 cereal, but she's going to have the 1 egg, which is 90 calories. So 0 calories for the serving of cereal plus 90 is going to give us a value of 90 calories. If her servings are 1, okay, she's going to have 1 serving of cereal, which is 210, plus the 90 for the egg, and that's going to give us 300 calories. If she is to have servings of 2, we need to think of 2 servings of cereal at 210 each, plus the egg. So 2 times 210 gives us 420, plus the 90. that's going to equal 510 calories. So there's 3 points of data. So we need this scale to go from 90 to 510. So let's think about this. If this went 0 and then 1, 2, 3, 4, 500, that would look about right. Okay, so we get up to 6. So this would be 100, 200, 300, 400, 500, 600. Okay. Now, plotting is going to be as accurate as you can, but sort of estimated. Okay, so we need to plot on day 0, so that's here. She has 90 calories, so halfway in between would be 50, and we need to be approaching to 100 there, sorry, so somewhere close to 100 is going to be the first amount at 90. The second serving of cereal, or the number of calories for breakfast, would be 300. So on one serving, that one's easy. We're going to go to 300. At 2 servings, we're going to go to 510. So 2 servings, there's 500. There's 550 again. We just go over 500, and there is our third piece of data. Now we need to decide, can this be, in fact, continuous or discrete? So, have some of you ever left part of your breakfast behind? Yeah, we know what the full serving would be, but she has the ability to not eat all of her breakfast. So she could have 1 serving where she left a couple of spoonfuls behind, or 2 servings where she left part of the egg behind. Okay? So, in fact, this is not discrete. We can have portions within that. So this then should be joined with as straight a line as you can to show, in fact, that it is continuous, that we can have parts of servings to, in fact, reduce the amount of calories. So the number of calories depends on the size of the serving and then how much of the serving she's actually eating. Okay, so this one would be continuous because she can eat part of a serving. Okay, hope this helps. Good luck. You want to be working on your discrete and continuous assignment now. Okay, bye-bye.